Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri, and we are here with Gadi. This is our inaugural episode for Season 3. And Season 3, we decided to focus on application security. Gadi, would you like to say a few words and introduce yourself?
Absolutely. Really great to be here with both of you. Thanks, Evgeny. Thanks, Dimitri. Excited to be on this series talking about application security. To share a bit about NeuraLegion, who we are in 2 seconds. We've been around for about 3 years. Our focus is on developer solutions around AppSec and APIs. And we started about 2 years ago to provide a DAST solution that is intended to help organizations shift left very significantly to the extreme left, right, and run DAST scans, so dynamic scans, but as part of their actual continuous integration, continuous delivery unit testing, so very early in the process. And the solution goes from what we call build to compliant. So developers can use it, DevOps people can use it, AppSec professionals can use it. We'll talk about some of those aspects throughout this, but we believe that as the world has changed into a DevOps or DevSecOps world, you have to enable developers to use these solutions. You can't rely just on AppSec professionals, and that's why it's very important to do these things.
Excellent, Gadi. Thank you for a great intro. If you're looking at DevOps, DevSecOps, CI/CD pipeline, we know that it's very complicated process that usually used to develop software, to build software, to test it, to deliver it, and also very important to make sure we are securing whatever we're building and releasing, especially after recent events of software supply chain compromise at the end of the last year. If you're looking at our CI/CD pipeline, where in the pipeline would your solution give the biggest benefit to the users?
Absolutely. I think if we can, as we said, let me share my screen. I'll show you our version of how we see this information and how we believe it is changing over time. So hopefully you can see my screen now. And what we've seen is if we look at the CI cycle or the software development life cycle, historically, DAST solutions could only be run in what we call stages 4 and 5 here, in pre-production and production, right? Because they took a long time to run, the solutions were complex, and only AppSec people actually understood how to use them and how to work with them and what the vulnerabilities mean. They had a bunch of false positives. There are many, many different reasons that you could only use DAST at those stages. What we have done and where we believe you need to run DAST is throughout the entire development lifecycle. So if I think about the coin that was termed about shift left, or another term that was coined around shift anywhere, right? We want to enable organizations to run the scans wherever they want. And it's up to us, the providers, and I believe that any provider should be able or should do this, to give the tools to the clients to run it. So if I'm a developer within an organization and we're more mature and more modern, we want to enable them to run these scans as part of their continuous integration or as part of their unit tests or maybe even as part of their QA. If I am an AppSec person or a DevOps person, we can run it either as part of the CI or on a production or pre-production environment. So the idea is to give every person the interfaces that they need and to adjust the backend to enable them to run scans very quickly. And we'll talk about a couple of examples later in the podcast, or run very comprehensive scans, fail scans quickly, or let scans continue, open tickets wherever is needed, but give people the tools that they need in order to run these scans wherever is applicable for them in their organization and wherever will be the most effective for them in their organization.
Gadi, I'm wondering, who will be your main customer? You mentioned multiple different people, developers, DevOps, security analysts, maybe.
Yeah, so we're actually seeing multiple users within an organization, and we're seeing different people using the solution at different times. Right, so it could very well be, and that's where we're striving. We're going further and further in that direction, where we see developers actually integrating the solution right into their unit tests and running the tests, the scans automatically, having tickets automatically opened for them in Jira or whatever ticketing solution they use, and vulnerabilities just become regular bugs. Right? Just like any other bugs, there's no reason that security vulnerabilities are not like any other bug, right? And then they can use them. However, we're also seeing that in larger organizations, ones that really want to drive compliance, we have AppSec users that want to get notifications about what were the vulnerabilities that were found, what was remediated, how quickly are things remediated, are they remediated on time? Do we have the same vulnerabilities in production? So the application security team gets to look at all the information, see the information, and get visibility, but they're not necessarily the people that are using the product every day, finding vulnerabilities, and then having to go back to the developers and asking them to resolve the issues. They set everything up, and then the developers can run by themselves.
Gadi, application security aiming to identify and prevent security deficiencies early as possible. How your solution contributes to this and how early you can detect these deficiencies.
So as you can see here, typically the first place where we can run and be effective, because we are a DAST tool, right? We can't run on the code itself. We have to have a compiled application. But the first place where we can actually have an impact is really at the unit test or integration test phase, right? Which is very, very early on in comparison to where you historically thought DAST solutions could run. And to see how this can actually work, we actually have two interfaces in our product. Right? One interface is the UI, and I know we'll jump into that a bit later, and we'll show the UI, which is usually used by AppSec or DevOps professional, but we also have a CLI that developers can use to run as part of their unit testing and write in an integrated way as part of their unit testing, and they can get the results right within their development environment. So the earliest that we can run is really in that unit testing and integration testing phase, and then you can build on top of that as the solution expands.
Would it require instrumentation of the code with some of your markers or pieces of your code?
The way that will typically work is we will have integration either into the unit testing environment or into, for example, the CI environment. And if we want to see how that would look in a CI environment, I have a GitHub Actions example, but obviously it'll work in the exact same way with Circle CI and Travis CI and Jenkins and JFrog and any other CI environment that you can run in. But you can see that when we have a GitHub repository, we have a HAR file, which is one of the unique components that we have. The idea is you do not have to rely on a crawler to crawl the end application. You can actually take the result of a unit test or a QA test with Selenium or something like that, which is an HTTP archive file, and just use that file that you've already created to scan the application. You can do the exact same thing with an open API file, right, that you've created for APIs. Ingest that and automatically run scans on APIs, or you can use Postman collections to run the scans on the APIs. That's not a problem. When we look at the YAML file in GitHub, there are three key things here. We're loading the HAR file, right? We are also defining and running our CLI to automatically install it to be able to run these tests, okay? And we are starting a scan. So all of this is configured as part of the YAML file. You don't even have to go ahead and run anything manually within the application. And the next step is to really run the scan. Right? So you can see that the way we run the scan and the rules that we set up here are First of all, go ahead and start the scan. Secondly, here are all the tests that we're going to run. You can see the different vulnerabilities that we're going to scan for, XSS, SQLI, CSRF, et cetera, a long list of them that I can show later when we jump into the product. And the next thing, which is very important that we defined here, is fail on first high vulnerability, right? So this means that if I'm a developer and I have 2 minutes to run this as part of the CI, I can have the build fail if I have a high vulnerability. And the minute that it fails, I can immediately go ahead and remediate and fix the issue. That doesn't mean that the scan can't continue running in the background and find additional issues while I'm doing that, but it doesn't waste any time for me, the developer. Okay, and then we can jump into the demo, but I'll pause for other questions before we do that.
Awesome. I understand you guys actually don't need access to the code because you run on the product when it's done. Can you elaborate a bit more, or like how often you can do it, or basically if I didn't finish writing my code, then I cannot run the tool? And when you run, where is the data saved or stored?
Mm-hmm. Yeah, absolutely. So definitely, as you said, Evgeny, we have to have some kind of compiled application, right? We can't run on just the code. And the earliest phase we can run is in the unit testing or the pull request, right? And when there's something for us to, that's not a binary to run on as a DAST solution. How often we can actually run? We have customers that are doing more than 1,000 builds per day. There are two different ways to actually deploy the solution itself. It can be a straight SaaS solution, right? So software as a service, you whitelist our IP address in the WAF or RASP or wherever is needed, and then we can generate the attacks. A second mode that we have is using a repeater. The repeater is installed on site, right, and enables you to test internal applications or not have to whitelist our solution or in your environment. And that means that every developer can have a repeater or multiple repeaters on their machine, and they can run multiple scans simultaneously without a problem. So we can run many hundreds or thousands even of scans per day. It just depends on what you're actually looking to do and what you're looking to achieve. And the idea is that you can define the length of the scan based on what you're actually trying to achieve. So if I'm a developer that's running this on every pull request and I have very few parameters that I'm actually scanning, scans will be really quick, right? They'll take 30 seconds. If we want, I can actually share the video where I took this information and you can see that the scan actually runs. We find a high issue, and the whole thing is done after 30 seconds, right? We fail the build and that's it. We also have clients that have sites that have 20 million pages, and the scans there can run for 2 days until they're done. So it depends on the scope of what you define as part of the scan, but you can limit and say, I only want this to run up to 5 hours or 8 hours or up to 5 minutes, and find whatever you can find. The other part of your question is, where is the data stored? So as you saw in my slide, we can actually have a direct integration into any ticketing tool. So if you're using Jira or ServiceNow or Monday or any of those, we can automatically open tickets within your environment. So wherever you're storing that data, we can open it. We do upload the information about the vulnerabilities to our portal, but you can automatically delete it, right? So you can set a rule to never store the information actually in our secure cloud, which is on AWS. But we've gone through multiple security questionnaires with large banks and governments, et cetera, and we've passed all of them successfully. So we're very confident on that.
This brings us to the next question, and it's around the known ways to classify vulnerabilities. How your product aligns with OWASP top 10 or MITRE top 25? Can you see this in reports, how findings are classified based on these standards?
Absolutely. Good. So let me, with that, actually hop over to the product so I can show a bit more there, or try to hop over to the demo, right? And you can see that when we actually run scans, you can decide which vulnerabilities you'd like to run those scans on, etc. There's a long list of vulnerabilities that we test for. You can see the complete list on the right here of what was actually run in this particular scan. As part of these, it definitely covers all the technical aspects, because if you look at OWASP top 10, for example, not everything in the top 10 is actually a technical vulnerability, but all the technical vulnerabilities that can be scanned for, we do scan for. And there's different profiles that you can use in the application to say, I only want to scan for the OWASP top 10, or I want to scan for the OWASP API top 10, which is different than the standard OWASP top 10, or I'd like to scan for Mitra 25, right? And that automatically selects the vulnerabilities that are applicable for that particular scan. By the way, you can also say, I want a fast scan, which means we're only going to scan for high vulnerabilities. I want a comprehensive scan. So you have different profiles based on what you'd like to run. And for every scan or every scan type, because they can be automated, you can select the relevant profiles. Then the next thing that we do is, in seeing the scan results, right? So I'm looking at a completed scan for broken crystals. By the way, broken crystals is a benchmark that we support. Anybody can use brokencrystals.com, run your own benchmarks on it, find vulnerabilities. It has lots of fun stuff in it. And you can see that, for example, when we look at a reflective XSS, and we're looking at all the data behind, oh, sorry, if I actually click the right place, that would help. And we're looking at all data related to that reflective XSS. We provide the CVSS information that's associated with it, right? And the OWASP definitions and OWASP information, and even remediation guidelines. And because we are a big proponent of no false positives, and we validate every vulnerability to make sure that it is indeed a vulnerability before we report it. Hey, we also give you things like screenshots to show you that, hey, this is what this vulnerability actually looks like within the environment. Okay, so to prove to the developers what the issue is, so they can actually go ahead and take action and take it in the right place.
Gadi, what kind of API you guys support right now? What types of API?
In terms of providing access to our system, or in terms of being
scanning.
able to scan APIs? Yeah,
scan APIs.
Perfect. Thank you. I wanted to make sure I answer the correct question. So when we're looking at scanning API files, there are really three major ones that we look at, and there are different types to upload them. So REST APIs, SOAP APIs, and GraphQL, which has been very big for some of our clients recently. We also support WebSockets, right? Which is a completely different beast, as you know. So we do support WebSockets, and we have a number of customers doing scans on WebSockets now. And you can, in terms of the files, you can either upload an open API file, so a Swagger, or you can use Postman collection. So we can import Postman collections and run on those.
Excellent. How about testing of SPA, single page applications?
Yeah, so if you remember, one of the things I mentioned, and if I go back to create a new scan, right, you can see that one of the things that we can do when we create that scan is either upload a HAR file, okay, or have the ability to just give it a URL. Right? In both of those cases, we can actually go ahead and expand different menus, etc., within the single page applications, and make sure that not only are we looking at expanding menus and drilling into the page itself and interacting with the page. So we have a component called the multi-parse. The multi-parse is a unique component that we've invested a lot in and enables us to not just look at the parameters and understand what the parameters mean, but also interact with them and expand menus within those single page applications. If there is authentication within the page, then we have a component called the authentication object as part of every scan to make sure that we can go ahead and authenticate into the right places within the application. So all these menus can be expanded and we can support multi-page applications effectively. Being very frank, right, we always find that there are more interesting, for lack of a better word, formats that people write single page applications, and we need to do some tweaks to support the full craziness that people are trying to do. I just had an experience with a client in Japan that had a very creative single page application with the menus written as icons, and we had to figure out how to work with that, but we figured it out because of the multi-parse that enable us to do that very effectively.
You mentioned that you can fail a build if you find a problem. Mm-hmm. I'm wondering, if I'm a developer, what's actually going to be the interaction? How do I know about it? Do I have an email log, or assuming I'm running the application and I will see it?
Yeah, so the build will actually, as you saw in the screenshot that I showed earlier, the build itself will fail right within the build. So whatever you're using for CI, etc., it will fail there. But you will get a notification that the build has failed, and automatically you will get more information about the actual vulnerability, right, and how to remediate.
But if I'm a developer and I'm not running the tool, what will happen? I'm somebody else running the tool.
Well, if you're a developer and you're not running this tool, then it's very unlikely that, or you're not involved in running the tool, that it will fail for you, right? There has to be this interaction. The developers and the security team have to work together. The security team can't just run this in the background as part of your build. What could be is that DevOps is actually running that build, and then that build will fail, and then you can automatically open a ticket for a developer. So the way this works is we enable you to integrate directly with Jira, etc., and open a ticket immediately for the specific developer based on the pipeline, and give them all the data that I showed around remediation guidelines. You can give them all of that information right within their ticketing environment.
I think this is the best way to do it.
Gadi, I have a quick question here. When you're doing this notification for a developer, the tool capable of understanding what were the latest commits into the repository that prior to identification of the vulnerability, and then notify the specific person, or is something that will just open the ticket and then the proper team that's responsible for the project will have to address it?
So typically we have the ability to decide for every repository either an individual or a team that the ticket will be opened for. We have integration with OIDC, right, to be able to understand the organization structure, who falls where, etc., and where these tickets need to be opened, right? Because we have some customers that have more than 1,000 developers, right? You have to open things in the right place, otherwise you'll be in trouble. Regarding the first part of your question, we actually do the polling. You can see that before we fail, we can do polling every 30 seconds to try to see if we found a high vulnerability. And then the other thing that we do in the previous slide is actually see when a commit was done and what are the deltas between the commits. So we can just scan deltas, which is very important.
So you can provide literally lines of code that counts.
So we don't, it's interesting. We don't actually provide the line of codes. We can see the delta in the build, right? We don't look at code because we're a DAST solution. But as you saw in the demo, we can provide the header of where the failure was and get you as close as possible.
We are done with the official part of the show. I have one topic that I'm really curious to learn about your product and your solution and your approach. Is there any capabilities of fuzzing in your product?
Mm-hmm. Yeah. So most of what we talked about today, because we're talking about integrations, et cetera, is our core solution, which is the DAST product. We have a complementary solution to that, which is actually where the company started, but we have since expanded into the world of DAST, and that's the core of what we do. We do have a fuzzer as well, and it's an application level fuzzer that enables us to identify zero-day vulnerabilities, et cetera. If you saw in the demo that I showed, you could actually select if you want the DAST or the fuzzer and which one you want to run. The fuzzer itself is mainly a tool that's really aimed more at application security people. It's aimed less at developers because of the risk that it poses. It's very aggressive, and you should assume that whatever environment you run it on, it will crash because the fuzzer will find a way to crash it. The other thing that's important about the fuzzer is that unlike the DAST, which is structured and you can say scan for these vulnerabilities and this is how much time you have to do it and it has to run very quickly, the fuzzer is just something that is AI driven. You unleash it and it starts running until it does damage. So it could run for a couple of days scanning an application, but it's very likely to do damage and find a 0-day at some point.
Absolutely. Generating havoc on the environment.
That's exactly what the fuzzer does. We do have an interesting interaction as well of, one of the advantages that we offer, which is, I think, very valuable and will be even more valuable long-term, is finding business logic vulnerabilities. So not just technical vulnerabilities, but also some business logic like date manipulation and things like that. And a lot of times the way we actually find those initially is through the fuzzer. The fuzzer enables us to identify those, and then we package it in a way that the DAST can actually consume it.
Gadi, any questions to us?
No, I'd love to hear what's the plan for the rest of the season. What are you most excited about in this world, and where do you see it going? You guys talk to a lot of people every day. Would love to hear your thoughts on where you see this going.
We plan to cover many different vendors in many different parts of the pipeline. And we are very excited to see vendors, how they help companies in their journey. I think SolarWinds was a very good example of the industry and where and how we need application security. And there is many different solutions that will help companies to understand. So we want to drive the adoption and the information to help people understand what they can do better with their development of internal applications, for example, or when they have a third-party vendor, what kind of questions to ask them, what they did to make sure their code is secure.
Yeah, I think that it's another way of saying that, and we use it all the time, is an ounce of prevention is worth a pound of cure. Right? And if you actually deploy these things as part of the CI and you remediate things early and you prevent having issues as early as possible, you will have to spend a lot less money dealing with the SolarWinds and with things like that later. So absolutely, I think that makes sense.
Thank you, Gadi. Thank you for being on the show.
Thank you.
Absolutely, really appreciate it. This is fun. Let's do it again.
Please remember to subscribe to our podcast and join us for our next episode.